Hi, we continue discussing the information unit structure concept on complex numbers. Today, I think we are dealing with the fifth segment of this discussion, and that's square roots, exponentiation, and natural logs. So we'll be dealing with that today. Still on complex numbers, square root subsection. The square roots of a plus b with b is not equals to 0 are plus or minus r plus beta I, where r is equals to this square root plus beta sine b, this square root, where sine is the sinum function. This can be seen by squaring. So basically this is an action. Complex numbers can be squared. You just use these two simplified formulas and then you will get the final square root of a plus bi. So it's an action. So which means we can give it yellow. It's an action. Complex numbers can be squared. Then we move on to exponentiation. Euler formula states that for any real number x, e to the power ix is equals to cos x plus I sin x, where e is the base of the natural log. This can be proved by induction and so on by considering the Taylor series ex. So if you simplify the Taylor series, this is what you get. The arrangement results is justified because the series is absolutely convergent. So this is just an exponentiation proof that you can simplify an exponential of a complex number. From this you can get the actual complex number. So it's an action. You can use exponentials even with complex numbers. So let's give it yellow. The next subsection is natural logs. It follows from Euler's formula that for any complex number z written in polar, z is equals to r in brackets cos theta plus I sin theta, where r is the non-negative real number. One possible value for complex number logarithmic of z is log z is equals to log r plus. So this is basically saying complex numbers can also be applied in natural logs. This is the formula which you use. So let's give it yellow. It's an action that complex numbers also work with natural logs. To deal with the existence of more than one possible value for given input, the complex logarithmic may be considered a multivalued function with log is equals to r. So if you've got more than one input, then having them represented as k, you can have a number of outcomes. So it's still an action. Let's give it yellow. So this marks the end of these sections. Now we go on to make notes, and thereafter of course we'll make notes. So now let's go on to make the notes. These are our notes for this particular section. Again, we still have got the Cartesian plane setting and the polar plane setting. The complex number unfolding on the Cartesian plane has these actions. And then the complex number on the polar plane has these possible actions. And then from these notes, we went on to derive the structured notes. These are the notes we have for the Cartesian plane. These are the notes we have for the polar plane. Simple, nice and simple. So you saw we compiled everything that we have from section 1 up to 4 and this section 5. So this is all we have for the 5 sections. This structured notes, all of them, they are for the 5 sections we were discussing. Everything is unfolding on the polar plane and the Cartesian plane. All of these are actions possible on the Cartesian plane. And all of these are actions possible on the polar plane. So the gist of this concept is all about having a clear picture in your mind about how information is structured and have that particular information represented by notes in your mind. That's it. Once you get that, then everything else will be simple. Applying these concepts on a problem that you have to solve, it will be extremely easy. And by the way, this method works for any field, whether it's sciences, whether it's history, whether it's accounting, any field you can think of, computer science, programming, whatever the field, this method works extremely well and it makes you more effective. So that's it for this video. Please don't forget to like, share the video and then subscribe to the channel. In the comment section, please tell us on which subject you will be using this method on. Where are you going to be trying it? Please tell us in the comment section. Thank you for watching. Thanks.